Hello and welcome to part 2 of the CPM help video. Alright, we're picking back up on 8-83, and it says use the zero product property to find the roots of the polynomials below, factor first if needed. We're going to do the same thing that we did in problem 8-71. We need length times width multiplied together, and then we're going to set that equal to 0 to solve for x. Okay, so I'm going to factor this polynomial. Polynomial is an expression of the form blank x squared plus blank. I'm going to factor this, set it equal to 0, solve for x. All right, let's do it. Diamond, rectangle, 3x squared here, 4 here. 3x squared times 4 is 12x squared. That goes up here. Negative 7x down here. Negative 3x times negative 4x is 12x squared. Negative 3x plus 4. Negative 4x is negative 7x. Okay, put that back into your rectangle. 3x times x is 3x squared. 3x times negative 1 is negative 3x. And then x times negative 4 is negative 4x. Okay. So I factored this as 3x minus 4, my length, times x minus 1, my width. You can put x minus 1 first. It doesn't matter. Okay, set that equal to 0 as a whole, and then set each factor equal to 0. Okay, 3x minus 4 is equal to 0, and then x minus 1 is equal to 0. Solve for x. So plus 4 plus 4, 3x equals 4. I'm going to divide both sides by 3, and I'm going to keep my answer as an improper fraction, 4/3. That's one of my answers. My other answer would be x equals 1. That's it. Okay, that's all you have to do here. Do the same for parts B and C. B you will have to factor first. This is missing a constant term, so like we did with last week's CPM set, if you're missing a term, you can put a filler in. You can put plus 0 so you can follow your usual steps. All right, next problem. Sketch each parabola below with the given information. And then it gives us parts A, B, and C. And I made a little note before that says you may not know where the vertex is yet. Remember, that's the tip of the U. Just approximate for now. All right, so I'm going to do part A. And I'm just going to make a sketch. It doesn't have to be perfect. It is only a sketch. Let's assume that I'm scaling by ones. So let's put 5, 10. 5, 10, negative 5, negative 10, negative 5, negative 10. This is my y-axis and my x-axis. Okay, for part A, we have an x-intercept at 2, 0, right there. Another one at 7, 0. And we have a y-intercept at 0, negative 8 down here. Oh, I'm not going to be able to draw a parabola going upwards because there's no way it's going to pass through this point. What that means is that my parabola is going to be opening downward. Notice that I just drew my best sketch because I don't know where the vertex is, but I can approximate, okay? I can estimate where it is. And that's all you've got to do, okay? Plot what you know. Part C, you can plug a couple points in for x to see what you get for y. Another little trick is the whole reason that we've been using the zero product property is because if we set each of these factors equal to 0, and we solve for x. Let me solve really quick. X equals -5 and x equals 1. These are our x-intercepts. Isn't that cool? Okay, so for part C, you have that information. You can plot 1 and -5 for your x-intercepts, okay? That's the whole reason we've been doing this, because it gives us useful information about the graph. Okay, moving on. Read this. Forms of a quadratic function. There are 3 main forms of a quadratic function: standard form, factored form, and graphing form. Study the examples below. Assume that a is not equal to 0 and that the meaning of a, b, and c are different for each form below. Okay, so standard form is when we have a quadratic in the form f of x or y is equal to ax squared plus bx plus c. Some useful information to know is that c gives you the y-intercept. For factored form, you have an equation that's either y equals or f of x equals, and then you have a, so some common factor that maybe you factored out, and then parentheses x plus b times x plus c. And just like I hinted at over here, when you solve here, if you set x plus b equal to 0, okay, you get x equals -b. Same thing over here. If you set it equal to 0 and solve for x, you get x is equal to -c. Those values are your x-intercepts, okay? The notation might be a little bit confusing, but what this is trying to say is what I mentioned up here. When you have an expression like this and you set each factor equal to 0, those values for x that you get are your x-intercepts, all right? And for this week, we're not going to worry about graphing form. Okay, 8-92, quality control, lots of dough. A wealthy customer would like to order a variety of parabolas. However, he is feeling pressed for time and said that he will pay you lots of extra money if you complete his order for him. Of course, you agreed. You're so nice. He sent you sketches of each parabola that he would like to receive. Determine a possible equation for each parabola so that you can pass this information on to the manufacturing department. I had already worked out an example for part A. I just told you that these were your x-intercepts and they go into your factored form equation, okay? So why does x plus 4 correspond with this x-intercept of -4? Because if I set x plus 4 equal to 0, and I solve for x, I'm going to get x is equal to -4, which is one of my x-intercepts. Same idea for the other part of this equation. Why does x minus 2 go with 2, 0? Because if I set x minus 2 equal to 0, and I solve for x, I get x equals 2, which is my x-intercept, okay? You can leave your equation in factored form, or you can expand it to write your equation in standard form. How do you expand this? You would just use a generic rectangle to multiply. X plus 4 times x minus 2. Then you would combine like terms. If you add all of these terms together, you're going to get x squared plus 2x minus 8. So you can write it in either form. I'm going to help you with part B, and then you'll do the other two on your own. For part B, notice that we only have one x-intercept. So instead of having something times something, when we have two x-intercepts, I'm only going to have something and then squared. Okay. What expression do I need in the middle? Well, if my x-intercept is a 3, I need x minus 3. So think of it as putting like the x and then the opposite sign and then the number that you have here. Again, that's because if I set x minus 3 equal to 0 and I solve for x, I'm going to get x equals 3, which corresponds to that. Okay, so try it for parts C and D. And then last but not least, 8-95 is going to be the same thing that we did in problem 8-83, where you factored in a quadratic and set it equal to 0 and solved for x. Okay, same thing. We also did that up here for 8-71. But you may need to factor first. So factor, find your product, and then set each piece equal to 0. Okay. I hope you find this helpful. Let me know if you have any questions. This is due Thursday at midnight. And then Friday morning, I will post the answer key so that you can make corrections and then turn in those corrections by Friday at midnight. All right. Thank you guys.